Hello, I'm Lewis Davidson, and I've been pondering how I could put out all my presentations in a format that would be watchable by plenty of people. And so I've decided I'm going to put out a set of database design chats. And I'm going to go through my presentations one by one, and I'm going to present them using their YouTube. And but I'm not going to put them out as they were. I'm going to put them out in small chunks, like 5, 10 minutes at a time. So first, I'm going to start out with just a personal introduction. Maybe you don't know who I am. Maybe you're like, who is this guy? I'm going to go through a couple of slides of just introductory information. First off, who am I? My name is Lewis Davidson. I've been an MVP for 17 years. And what this truly means is I don't sleep enough. Okay. I spend a lot of time writing presentations or worrying about writing presentations or working on conference teams, whatever. And a little bit different the last couple of years. So I've written 6 books on database design. I'm going to use those books as backup. I will also use other materials, as you'll see later. What this means is pretty much the same thing. Writing books is a time-consuming art, and I have actually one I need to start very soon. That was another reason I landed on this kind of 5-minute chunks of time, 5-10 minute chunks of time, because I can sit down and I can do this an hour or two a week and get out some material and really go over it and work on my presentation style, doing live presentations. I've been a data architect and a coder for over 20 years. And once you say over 20 years or somebody says over, that doesn't mean I'm 20. I've been doing this for 20 years and a month, right? I've been at the same company for over 20 years. So, and it was not my first company, and I didn't work there contiguously. So I've been doing it for over 20 years. I'm old. Okay. And old has 2 values. One is that I've seen a lot, I've been hurt a lot, and I've gained some wisdom. It also means I may be outdated in some cases, and that is a very true possibility. So I respect that, and I actually hope if you have better ideas, you'll put them in the comments. I would love feedback on these and all my presentations. There are 2 kinds of feedback a presenter likes. One is good. Everybody loves good feedback. You can say, I don't really care about good feedback. Yeah, I like good feedback. But I like really bad feedback with an explanation. There's some things I've done in the past when I'd write a book and I would get some bad feedback. And I got a couple of good bad feedbacks in the past where I learned that things that I didn't cover, things that I didn't know, things that I got wrong. I've written 6 books on database design. That doesn't mean I came up with any of those topics, right? Those were done by these mathematician people who are far smarter than I am. And I'm 100% ready to admit that. Part of the reason I'm maybe not as smart as they are is because I have other hobbies. And we'll go over those in just a second. We'll talk a little bit more about that. I'll give you a link to my other hobbies. So in the future, I'll link you back to Linktree and just say, go there and then get on with the presentation. Today's total introduction. Okay. So my hobby that started about 3 or 4 years ago is taking and posting theme park pictures. And we have a vlog, I have a blog. All that will be found on this link tree right there. Figments all over the place. And our vlog is called Figments in Time. And we talk about past things we've done in the past for vacations. And figments all over the place because I have way too many things going on. I'm a Dollywood influencer. I'm one of their insiders, which is also linked there. I go to Disney World a lot. I take a lot of pictures. But one of the things I do, I have to leave that in. One of the things I do try to do is use my knowledge from many years as a data architect to putting together these pictures. And what I use is I actually have a database and SQL Server on my machine here that has a lot of pictures, thousands, I think about 7,000 pictures in my two databases, cataloged and named, and I can search for them and I can randomly pick it out. We'll talk more about those kind of details and ideas for how you might implement like special scenarios later after we get past a lot of the introductory material. Okay, so that's all about me. All right, so let's get into the technical talk. So the one most important thing when you're going to build some piece of software or really anything, let's not talk about what it is. Let's talk about what it isn't. What are the characteristics that aren't the most important thing? Is it how well you build it? No, not exactly. Right? The structure, I'm gonna go on quite a few times about normalization and good practices and things. Those aren't necessarily the most important thing. Does it matter how fast it works? It matters, but is it the most important thing? No. Does it matter if it's quality? I mean, is quality that important? Not exactly. Is technical impressiveness? Does it matter that you've used the newest, latest tool and you've impressed your boss with this? Or you've been able to write a blog or the MVP award, you get it because you use their new technology? It doesn't. It really doesn't. Does it matter that it looks pretty? There is a lot of really ugly software out there that you just can't imagine. What about replaces manual processes? Did you successfully replace some manual process people have to do? I love it when I go to the car. Well, I don't love the overall thing, but I love it when I go to the car dealer and I'm picking up my car after it's being serviced. And the person sits there and I go, can I have my keys and how much is it? And they go, okay, just a second. And then they sit there and they start typing. And I'm like, 5 minutes at times where they're like just typing. And then they go, okay, here you go. Thank you. And you're like, what did you type? Did you explain it again? Because when they write it in, just when you give them your car, they write enough stuff of it is this and this does this and this does this. Customer states that. Right? Who else stated it? Right. So no, it doesn't matter. That's a perfectly acceptable solution if it does one particular thing. Okay. Is it normalized? Well, it doesn't even matter that you use a relational database. I love relational databases. We will focus on that more. I may stretch out beyond relational databases as I learn, and I may go from database design chats where I'm trying to tell you something to I'm learning something. I'll read a book. Just sit here and I'll read someone's book. Yeah. Chapter 1. It doesn't matter. It doesn't matter that it's used SQL Server. It doesn't matter if it's Oracle. It doesn't matter if it's relational at all. Again, we talk about it doesn't matter if it's easy to use. It doesn't even matter 100% if it's security based, if it's secure, right? All of these are crucial, okay? No doubt. I'm not suggesting that any of these things aren't topics that we will A, talk about, and B, you need to be considering. You do want to have good structure. You're doing it normalized. You're doing it using a product that works. What really, really matters is one thing, and that is that it's correct. You build a piece of software and it does what it's supposed to do properly. If it does it in the most convoluted, screwed up way, that is 100% better than if you wrote the most technically beautiful looking piece of software and it doesn't do what the customer wants. All right, so correctness. How do we define correctness? Wikipedia, which is, I admit, not necessarily the best place to define correctness, but it's free and it's quotable. So they define correctness in computer science as, in theoretical computer science, an algorithm is correct with respect to a specification if it behaves as specified. Okay, I like that. Best explored is functional correctness, which refers to the input-output behavior of an algorithm. For each input, it produces an output satisfying the algorithm. Best by the specification. Fantastic. That is really, really true, and that's kind of the goal. The key, though, is this word specification. We need to make sure we understand the specifications and what it's supposed to do, because too often we write software that's beautiful, that does something that meets our specification, that doesn't meet the customer specification. And that is bad. Okay. Now, correctness. Obviously, I'm saying correctness is the most important thing. Your software needs to be correct. But let's be just a little bit reasonable. Software has bugs. Your software has bugs. My software has bugs. There's no doubt about it. What is important to understand is that you get as close to correct and you do as close to what you've been asked as possible. So there's no way to write like the perfect piece of software unless it's really simple, because there are millions and millions of different things that can happen. For example, let's say you're writing software to add two specific numbers together. I mean, if it's just two specific numbers, 2 plus 2 is 4, I can hard code the answer and that's great. But if I can add any two numbers, let's just take integers. Let's just take the basic integers. There's 2 billion, 2 billion positive integers even. To test this, I need to add every one of these 2 billion integers to every 2 billion integers and compare every single output. That's not happening. Even if that's your only software assignment for the year, that's not happening, right? Because you would then have to have all those answers stored and compared. And you're talking just tremendously large amounts of number. We have to trust that basic algorithms work. And once we define the algorithm, we trust it. So if you have a column that stores a number, and you say this number can be anywhere from 0 to 2 billion, you're not going to test every one of the 2 billion values. You may not know that at 275,322, there is an optimizer bug that causes it to behave weirdly. Okay, you may not know that. That's okay. That's not the kind of correctness I'm talking about. The kind of correctness I'm talking about is where the customer says, I'd like a system to inventory my images for my social media campaigns, and you give them an invoicing system that invoices widgets, right? That's what I'm talking about. And it's usually not so particularly far apart, but usually the differences are subtle enough that nobody notices them until you get to the final. So this happened to me early in my career. It was the first time I was a consultant. And we did this project where, somebody interviewed the customer, got their specifications. We followed them, even though they didn't make tremendous sense. But then we got punished because those requirements didn't make sense. Okay, so as a team, we didn't do what the customer wanted because the customer wasn't really asked. And it's a lot of subtleness there. Okay, so we'll cover that in more detail later. Pros and cons of good enough. Good enough is the killer of all killers. Is this good enough? Well, what does good enough mean? We'll talk about that. All right, so that's the end of episode 1. Correctness is the most important goal. Just make sure that you do what you are supposed to do. If it takes a little longer, if it does a little better, there's things like security you can't really waffle on, but still the first thing is it's got to be correct. Again, a very secure application that doesn't do what the customer wants is still not good, still not exactly what people want. All right. If it doesn't do what the customer wants, it's the worst piece of software created. Okay. Understand the problem, first solve it, then solve it. That's my point for the day. Thank you very much.